Gentlemen, welcome to our video on how to solve pedigrees. Now, you have learned what is a pedigree. You filled in your big long chart. Then this is where that chart comes into play. Now you are going to rely on this chart heavily. So please make sure you have it as you're going and working through your examples. The examples I'm going to do are found in your note package. I believe they are the ones that you need to solve. It's like 5 pages of pedigrees of solving. So follow along with me and see if you can find this one specifically. Watch it a couple times to help you understand what we're trying to do. So in a pedigree, we understand how to read it. There's a bunch of generations, a bunch of people in those generations. Shaded people are affected people. But what we're looking for is how is that passed on, the transmission of the trait. Is it autosomal dominant, autosomal recessive, or sex-linked recessive, or sex-linked dominant? We don't know. We need to figure it out. So what we do in Bio30 is we go through and we give evidence to show what it probably is not, therefore making it this, a possibility. Now, pedigrees are very difficult because sometimes there is more than one answer. So please don't get frustrated as you do this. If you have questions, please let me know. I'm going to get started. I always personally start by trying to find out if something is recessive or dominant because I can see it very quickly. I understand that it is a very easy one to pick out. If you watch other videos on how to solve a pedigree, that may not be the first place they start. So you can maybe look up a few other ones if this method is not working for you. What I'm going to do is I'm going to start and I'm going to look at my first generation. I have an affected parent. I have an affected parent in my generation. I'm going to go down to generation 2 and I'm going to look at their children. And what I'm seeing here is that they have affected children. And what I'm seeing also is their children, these affected parents now, are having affected children and having affected children. So what I'm seeing is that this trait is carried on in every generation. This may throw you off. You're like, oh, look, it skips a generation. Nobody is affected. But you have to look at the generation as a whole and you have to look at it all the way down. Okay. What I'm seeing is that it shows up in every generation. And as a parent has a child, that affected gene is passed into every level. So I'm going to say that this does not skip a generation. So I'm going to say no skipping. And what no skipping means to me is that right away tells me that I have some sort of dominant trait. Because if you look at your chart, the very first thing we wrote is that recessive will most likely skip and dominant does not. So I'm proving that this is not recessive by saying it does not skip. Instead, it is dominant. Now, the nice thing about this is now I can just look at my X-linked dominant chart. Because now what I have to do is I have to prove that it's not X-linked. There are no real rules for autosomal dominant. It's just skipped a generation. If you have one affected parent, you can have affected children. That doesn't help. But there are clear rules in X-linked that allow for you to figure out, is this X-linked or not? You can prove it's X-linked if it follows most of the rules. If it does not follow a rule, it is probably not X-linked. Well, what are those rules? Well, X-linked dominant says if a father has it, all his daughters have to have it. So I'm going to pick this father right here because he has had children. And I'm saying, I want to figure out if this is X-linked. If this was X-linked, let's pretend dad was this. I'm making this up. This is not true. This is not what it is. I'm just making this up. So he's X big H Y. That's what I'm pretending I think dad would be. Now, dad can only donate this to all his daughters because he donates the Y to the sons. So if he has daughters and this is an X-linked disease, all his daughters have to have it because they would get the dominant allele. So let's look. This daughter has it. This daughter doesn't count because she's married into the family. This daughter doesn't have it. She does not have a dominant gene. So I'm going to say, because of this right here, this is not X-linked. Why? Because I have a father that had a daughter who didn't have the disease, and that wouldn't happen in X-linked because dads can only give their X's to their daughters. I'm going to look around and see if this happens in other places, and I can see right here it happens again. So this father had a daughter that wasn't affected. So I can probably say most likely this is not X-linked. You can go through and look at the other pieces of evidences of sons If a son has it, a mother has to have it. So here's a son, his mother has it, son, mother has it, son, mother has it. Okay. Son, mother has it. So if I only looked at one piece of evidence in my X-linked dominant, I would say, yes, this is X-linked. But you have to be careful because if at any point in time I can prove it is not X-linked, it can't be. It can't be passed through mums on an X, but not through dads on an X. It has to be all X-linked or not X-linked. So at this point, I'm going to say this is autosomal dominant because I proved that it is not X-linked for the father to the daughter. Okay, so I apologize. I'm using my mouse to write, so this could be a little messy. So there is my choice of autosomal dominant and my little reasons to why I chose it not to be the other. So when you're trying to prove, you can circle and then say something like rule 1. Oops, there's an L there. Or you can write it out for me. Father has it, daughter does not. Okay. But I wrote no skipping dominant. So this, I've solved this pedigree. I've made my choice of autosomal dominant is what I believe it is. Let's look at another example. This one's a little bit different. Again, I start with the does it skip generations, does it not? So here, it's not found here, but it's found here. It's found here and it's found here, but it's not found here. So I can see that this is not in every generation. If you don't have the disease, okay, sometimes you have children with and sometimes you have children without. See, none here, nothing. So I'm going to say this skips. And because I'm saying this skips, I'm saying it is autosomal. Now again, oh, sorry, not autosomal, recessive. Sorry, I got ahead of myself. Skipping generations, so I'm saying it's recessive and not dominant. Ooh, that's really bad. What I need to now prove is that it is either X-linked or not X-linked. So I'm going to go to my chart and I'm going to see that there's a couple of rules. It says if parents are affected, then all their children have to be affected. That's one of the rules in recessive in general. And I see that here. These parents are affected and they had 2 children that were affected. These parents were affected. They had 2 children that were affected. Same here. That's again just proving that it's most likely recessive. It skips a generation. You have these parents that are affected with all their children affected. That's again just showing more of a recessive than autosomal or dominant. I'm going to go back to the rules of if a daughter has it, her father has to have it. And if a mother has it, all her sons will have it. So again, I'm going to look at these 2 rules and I'm going to try and prove, okay, that it is this way due to the 2 rules. I'm going to look if a mother has it, all her sons will have it. So I have a mother who has it and her son has it. I have a mother who has it and her sons have it. I have a mother who has it. Oh, okay. Her sons don't have it. Interesting. So there's one piece of evidence. A mother has it. She has no sons. So I'm going to go back here. I'm going to circle this area right here. If this was X-linked, mom would be X little h and X little h, meaning she only has one option to pass on to her sons, and it would have to be the recessive allele. Therefore, her sons should show recessive traits if this was X-linked. So I'm going to say this is not X-linked. I'm going to make sure for sure, even though I said before, if you can prove it once, it won't be, but let's just make sure the other rule works too. The other rule is if a daughter has it, her father has to have it. So I'm going to go through and look at the daughters. Here's daughters. The son has it. She doesn't count because this isn't her father. A daughter has it. Her father has it. Perfect. Daughter. Ooh, here we go. I found another reason why it cannot be X-linked. Because, again, a daughter has it, her father has to have it. The reason why is because this daughter would have to, again, have 2 little h's to be a recessive phenotype. She would get one for mom and one for dad. There's no carriers for males. Mom could be a carrier. She could show unaffectedness because she could have this and this. but dad would not. Dad would have to have the affected allele and it would come and pass on to the daughter. Dad doesn't have it here, so again, it's not X-linked. Oops, it's not very good writing. So for this purpose alone, I'm going to say this one is autosomal recessive. And I'm going to choose that as my transmission, my mode of transmission. All right. So this is two ways in which you can solve pedigrees. I will write out and give you the answer key for all the other ones, and I will talk to you soon.